title is Spatial User Interface, and I'll just quickly, I mean, I've already been introduced, but so when I'm talking about tangible XR, what I really mean is that it is working at an intersection of TEI and extended reality, right? And my lab is sort of dedicated to exploring this. And I also have a startup, fairly recent, that sort of tries to bring all the research that we do to market, right? So there is this pipeline that we are trying to explore. If I tell about my lab, it is mainly a design research oriented lab exploring HCI aspects, primarily from interaction design of XR and TEI. These are some of the works that I'll quickly show you what we have been up to so you can get a sense of the type of things that we do. A lot of things we explore are dealing with emerging tech, and they are also, in some sense, some of the outputs are artistic in nature, right? So we work at intersection of new media arts as well. So, for example, one of our work which dealt with augmented reality and how it can be utilized for tourism. And this was sort of an ethnographic study where we went to the site and we started understanding how tourists behave in a particular space, and can those insights be then translated into an application, right? And specifically with AR, or or in terms of tangible interaction, if I talk about, can we create or give physical forms to intangible knowledge, right? So covered is basically a very or it's an old practice that happens in Rajasthan, and this was one of the works that we did in terms of converting it into an interactive installation. And other works that explore primarily in terms of arts, basically, how you can have these interactive setups. This is jail diaries, and this is again interfacing multiple modalities in the sense with XR technologies. So, for example, in this work, we were exploring olfactory interfaces, something that you can smell. And a contraption was created, and if you can scan the menu items, you would smell those, dishes. So the idea here really being that, and in fact, if you see the underlying theme in all these work, the underlying theme being that we would it's a Bharat-centric view that we are approaching. We are trying to weave in the traditional knowledge, the heritage, and marry them with the new technologies that are there. So this is another work that is there, which sort of explores tangible and XR together, wherein this sand table that you see is a tangible interface with a projective AR, if one may put it in that way, and it is also interfaced with a virtual reality device. What it helps users do is basically get a sense of, basically they can craft any terrains physically with this, and show you the video. So the users can craft the terrains through the sand, and it was based on some initial works done by Hiroshi Ishii, like on illuminated sand and other things, and eventually the topography is presented to the users, and this can be then viewed through a virtual reality headset, and the users can create different type of terrains in this one, and they can also overlay different tangible tokens, physical objects on the sand, which are recognized, and accordingly they spawn in the virtual environment. So, and these are some added functionalities in the sense that the users can draw different type of terrains. So, for example, this is snow. They can perhaps draw deserts. They can draw a different type of, forests, etc. And then view it inside a virtual environment in 3D, or it can be interfaced with a VR headset for them to experience. Now, this is one sort of work that we say it's exploring the tangible XR components, right? And we've had multiple explorations with the sand table in our lab, wherein we sort of combined it with GenAI for generating visuals and used it for children to understand how print play can happen. And some other form of work that we do in that sense is also exploring novel interaction paradigms. So what if your curtains become interactive, right? And this work sort of explores that, wherein we embed different type of interactions in physical environment, and they become functional, they become assistive in nature, further augmenting their capabilities. So for example, if you could turn on and off the smart appliances in your home, right, with curtains, or if you can flick television channels, and the use cases can be like explored, different use cases can be explored in the sense. Exploring VR for different use cases, and AR also again for tourism and other purposes, right? So these are some very early works that we have done, and trying to understand how we can combine all these technologies together. So for my focus for this session will particularly be on understanding how these computing devices have evolved, right? And specifically displays, if I would say. And with this emerging paradigm, how do we design for them? What are the design processes? What are the design guidelines? And second, and the lastly, like what is the part which through which you can really turn them into into a spatial interfaces, all these different things, right? So let's begin, right? And this is one interesting cartoon that I stumbled upon on the internet, which sort of tells the way how display technologies have been evolving. But what really got me was because the interacting with CRTs was quite easy compared to what we have now with these fancy displays that we have, right? The information in them is quite a lot, and so is the interaction. It all started initially with different computing devices, maybe ENIAC, and with Sage displays came in. Sketchpad was an interesting development which uh, made computers interact in a more natural way with humans because you could draw, and drawing is something that inherently comes in if you want to sort of explain certain concepts. Douglas Engelbert's mouse was, I think, a pioneering milestone for HCI in some sense, right? And what we see over here is a snapshot of Dynabook, which was, you can say, in 1972, that was an early version of iPad that was conceptualized by Alan Kay. And there were different evolutions that happened, right? With all these computing devices evolving, the display coming in, and the interaction devices coming in. Um, Around 90s, we had something called as Windows, right? And as in like the interface I'm talking about, which really had these icons and mouse and pointing devices. And the guidelines for them at that time were new. We did not know how to design for them. And eventually they evolved, right? And these are now like well-established guidelines and principles that we have for designing 2D interfaces. And there have been multiple, what you can say, evolutions that have taken place where in terms of multimodal inputs or interactions, in terms of computer-supported collaborator work with Boomer and Internet, and the idea of ubiquitous computing and more than variables. And now we are talking about something called as spatial computing. So what you see is primarily that uh, it was mainly towards the physical environments, the reality based. Then we had this whole desktop and mobile computing era. And I would say mobile computing era is predominant now. And slowly the paradigms are changing towards heads up computing, wherein the interfaces have become more and more natural. So the whole idea of this paradigm being that we move from a device-centric view to a more human-centric view, and instead of moving around the devices, can devices move around humans, right? And in fact, that this has been the underlying thought: can we design things that are more human-centric, more easy for us to understand? And this brings me to the display technologies. So the evolution of these technologies has been quite interesting. I mean, from early on, and I would say, with Morton Hiles, Sensorama, and Ivan Sutherland creating this first AR headset or a VR headset, right? And in 1979, this vital helmet was created for defense applications and cave displays, and it sort of evolved, right? And some earliest example we see is somewhere around 1862 with Pepper's Ghost, wherein the reflection principle was used by John Henry Pepper to create illusion for the haunted man and the ghost's bargain, this play that was held in London. Simply, I mean, simply put, this is how it sort of interacts. You have this glass over here, and you're putting lights which are reflected, and there is this reflection that the participants see, and this becomes like an illusion, and it's quite entertaining. And we see multiple applications of these nowadays, right? Um, this is the earliest work by Ivan Sutherland, which was trying to understand how we could place information in terms of human, in terms of the uh, for humans to understand, right? And it is directly placing these information in front of your eyes. Or Sensorama, which, if you really see, it has this 3D vision. It has color, it has aromas, wind, and vibrations. So these are some early works that explore or that tell that how we have been sort of always curious if we could live in or escape into a virtual environment in some sense, right? And the evolution of headset has also been pretty interesting in that sense. And I mean, there was a break in between, just like AI had a big break in some things, right? The cold winters. So somewhere around 2010, I would say, there was a long gap for all these VR devices and other things to come in by. Eventually, the evolution started with Oculus, and now there are like different devices that are existing in the market with different capabilities. At the same time, it is also interesting to note that as the headsets have evolved, so has the wearable computing, right? And earliest pioneers in this space of creating wearable computing, wherein miniaturization has happened. This is one of the snapshots of Snap's spectacles, right? Wherein you can see things in air quite condensed. So one of the like uh, Milgram proposed this continuum, which was from reality to virtual reality, wherein you have a complete real environment, and then you have a complete virtual reality where it is completely immersive and it is cutting you off from the real world. So this is basically a taxonomy of displays. What if different type of displays that can come in, right? And AR and virtual reality is sort of somewhere in between, and it is also primarily a mixed reality dominant view. So what it is saying is that this is the reality. In AR, you're juxtaposing some 3D information. In augmented virtuality, the environment is virtual, but there may be some real objects inside it. And in VR, everything is virtual. So sort of like this, right? This is an example of AR, the very first thing that you're seeing. Then you're seeing the second example, which is mixed reality, which is aware spatially, which is aware of the environment. And then you have VR, which is completely immersive and completely virtual. It's a completely synthetic environment. Um, and this is one example that sort of explores or explains what augmented virtuality is. And this becomes important. And why I'm dwelling much deeper into these AR, VR, and augmented virtuality and augmented reality is because as designers or as someone who would like to create different experiences, you would want to understand what are the capabilities of your devices or what are the possibilities that are existing, right? So it's not just the headset. You can move beyond headset in many cases, right? So what you're seeing in this example is the food is real. This is basically a dining experience that is being tested. So they have created a virtual environment, maybe of a restaurant or something, and inside it, the people can experience the food. That is the real component. So this is one example of augmented virtuality. Or, for example, in this paper, you invaded my tracking space. And this is one thing that you may sort of understand.
I think you're muted. We are not able to hear you, Dr. Anmol.
Right. So, what you're seeing in this particular example is different ways in which you can sort of bring people inside a virtual environment, right? And a nice example, I would say, of augmented virtuality. Um, and we are seeing convergence of these devices, right? So, this is one video by Microsoft where they bring in different uh, like you see a hologram over here, you also see a person wearing a headset, you see a digital avatar, and that is where the world is moving, right? Initially, there was a time wherein there used to be a distinction, but now with all these devices and the capabilities in computing, we're seeing a convergence. So, just a quick recap, VR is completely synthetic, AR enhances it by some juxtapositions, right? Wherein the goal of VR is to provide autonomy and agency to the users, wherein you are able to track your head, you can use body as an input. Uh, Gestures, speech, and other things can be utilized as modes of interaction, and you have some sense of presence, right? And there are different types of VR that exist, different type of headsets. And fairly recently, we have seen this evolution in something called as pass-through VR, wherein now you don't have this, wherein you're seeing the world through the lens of a camera, right? And which is projected through these lenses inside the headset. So this is supported in HTC Vive XR Elite. This is supported in MetaQuest Pro and MetaQuest 3 devices, right? And this is just one example. So if you haven't experienced MetaQuest 3 per se, you can see, or MetaQuest Pro, you can see this, wherein you are able to see interfaces through the lens, right? And then we have Apple Vision that has fairly recently stepped in and uh, bringing a new mode of interactions, and now also making the word spatial computing more advanced and more famous, right? Um, and really, like there are a number of display technologies out there and different ways in which you can just interact with things, how you can interact with virtual environments. VR technologies are of different types: 360 videos, stereoscopic displays, cave displays, and different type of tracking mechanisms, spatial audios, and domains and applications are enormous, right? It can be used in medical, it can be used in training, for entertainment, and different applications altogether. So let me just fixing some issue. Now, AR, Google Glass was an initial device that came in and sort of tried to push AR in that sense. Although the device did not lasted long, but it sort of gave a framework to move forward in this direction, right? And they had different projects that were running wherein you could have real-time translations and you could also see them through these glasses. But altogether, AR is the juxtaposition of information that happens, and we have seen applications through on different platforms like Amazon or IKEA using them, wherein you could just look at a particular space, place your or look at it from your mobile phone and just place virtual objects in this particular space and see what may happen, right? So, using for place buying furnitures or for buying food for now, right? Zomato or some platform introduced, you could see the food in 3D. So it combines both real and virtual objects together and provides an interactive real-time visualization, which is registered in 3D. And they are of different types. So it can be marker-based or markerless, or it can be based on projections, right? So you see this example wherein they're just trying to project different information on a shoe, and they can change the patterns, etc. So this is one way in which you can also bring in augmented reality, which I would say is spatial AR in some sense. And different devices like Magic Leap, which are coming in. And you have different concepts: augmentation and mediation, strong AR, weak AR, and markerless. And an example being that you can overlay information, which is augmentation. And with filters, you can do mediation, wherein you are able to beautify yourself, you are able to maybe make yourself bald, age, etc. Right? So this is the mediation aspect that comes in. Or different mixed reality headsets, which such as HoloLens, through which you are able to understand the context. And mixed reality is one term that has been sort of a point of discussion in HCI community quite long. And these are just some of the views that you can see, right? It's a reality virtuality continuum. It's synonym to AR. It's a combination of both AR, VR. It's a stronger version of AR. And this then brings us to what strong and weak AR is. So Google Glasses per se would be something like a weak AR. And if you're viewing it relatively from your mobile phone, that becomes a stronger AR, right? And different type of displays that are there. And what it means is more playground to play with and understand how you can create spatial experiences. So the question then becomes is how do we design for these emerging displays and interaction paradigms? We have seen different capabilities. We have seen capabilities in terms of spatial projections. We have seen capabilities in terms of devices, the way you can interact with them, right? So fairly like with 2D interfaces, we have good or graphical user interfaces, we have good amount of principles that exist. And one of the fields that looks into this is user experience design or interaction design, which really tries to understand what happens or how do people use different digital products, right? Which context are they using in? Are they appropriate? What is the activity during which these devices or product is to be used? So it sort of deals with understanding how you can create interactions that are effective, useful, and usable. And the whole process is strongly rooted in a user-centric design approach where you are taking in requirements from the user by interacting with them continuously. You're prototyping things, evaluating, and then designing alternatives. So this becomes like a key cycle. And in fact, one of the ways in which you can go about in designing your experiences, right? So as interaction designers, you should be sensitive to how people behave, reach, act, respond, and how they will use a product in a certain context, right? And one of the focuses being usability, wherein the principles really mean that functions should be visible to the user. It should be telling users or giving users feedback on a certain action that is done. If there is an unwanted interaction, it should be constrained and restricted. There should be consistency in terms of the UI elements, and most importantly, the affordance, which should let people know what is the intent of the interface or a particular element that you have put in, right? And the goal really being that it should be memorable, learnable, it should have some utility, it should be safe to use, efficient, and effective. And this becomes like the fundamental thing, right? Because it becomes like fundamental quality of user experience, wherein you have to engineer it from the very beginning. So, for example, if you look at this part, right, usability is basically um, looking at effectiveness, efficiency, and satisfaction with which the user can achieve specific goals. There is an ISO standard for it, by the way, and we primarily look at effectiveness, efficiency, and the satisfaction that users get when they're doing so. So, it should be intuitive and efficient. It can be conceptualized in different ways when you're designing products or interfaces. In the sense, it can really be having a visual quality, the quality of build that it has, and the type of or the quality of interaction that is built in, right? And it involves designing for ease of use, to understand how the communication is happening, to understand what happens inside the mind of the users, right? You create different mental models, you sort of embed their cultures and behaviors together. The overall goal being that you are creating something functional, efficient, safe, friendly, and having a pleasurable or an enjoyable experience for the users to use. This one of the some of the principles that exist, which are fairly well established in user interface design, are Nelson's 10 heuristics for usability, right? Which focuses on visibility of system status, wherein the system should always keep the user informed about what is going on. The user should be able to understand the elements that are there in the digital space, right? So, for example, and this is what we're calling as metaphors, there is a physical calculator and the same is replicated in a digital world, which is acting as this, or the folders that you see, right? So it is in a language which is very similar to users. It should tell people about navigation. If they make mistake, clearly there should be some way out for them. And it should support in doing them actions like undo or redo. Consistency is an important bit, and that is why you're seeing different interfaces. They are all consistent nowadays, right? Wherein this is one snapshot from the MS Word, which shows consistency of elements across different versions of it, right? And the search bar, for example, on many websites, you see they are consistently over there all throughout. And in case you make a mistake, the system should, or the interface should be in a way that it helps you undo that error. It should help you prevent a problem from occurring in the first place. But in case you do it, you should be able to recover from it. And it should be primarily based on recognition rather than recall. So you see all these interfaces over here, the elements or the menus, they are similar across different applications because you are easily able to recognize them. It's not like you are recalling them again and again. Right. And it should be really easy for users to interact with things. And aesthetic and minimal design, wherein a lot of information basically clutters the information processes, right? Because too much information makes choices difficult for users. So you should design interfaces in a way that are that basically contain important information to users for users to interact with in the first place. And it again encompasses different things of aesthetics and visual interface elements, right? How you're going to design them. And it should help users recover in case they make a mistake, they are able to sort of work their way through. And some help and documentation is always required. In case the user is getting stuck somewhere, they should understand what, or if they should have some sort of a guidebook for them to work on, right? And then there are some really interesting laws that exist, like Fitts law, Hicks law, and magical number, or Miller's law, Pocoyoke principle, and Tesler's law, which is really telling about the movement in the first place, right? So the Fitts law primarily deals with understanding, how much time it takes to move from one position to the final target. It is based on the distance of the target and the size of the target, right? So for example, you see these buttons which are there in Amazon, the buy button, it's pretty big. So you're easily able to reach over there through with your thumb, right? And you see these different applications. For example, Google recently introduced the search bar at the bottom of the screen, which is increasing the reach. Um, Too many choices make it difficult for users to understand things, right? So keeping it simple is the mantra over here, which you see all these websites, right, which are cluttered with information, and thus makes it difficult for users to understand what elements they have to click or how they have to navigate. But keeping a simplified interface is easy for users. So the more choices you provide to the user, the longer time it takes for them to make decisions, right? And it sort of overwhelms them. And it's also in line with understanding how we understand and perceive or remember different type of information or pieces of information. So for example, too many choices versus this one, right? So this becomes easy for users to imbibe. Um, and so this is one principle, Pocoyoke principle, which you can say that also deals with the way you design things, that it should put in constraints to prevent errors for the user, right? For example, your brake, it's quite big, right? This in the car. It's primarily because it is helping the users to immediately put on brakes in terms of something to happen, right? So how do we apply these principles to AR and VR? So the same principles can be used in terms of augmented reality. So with AR, you can give visual markers to user to help them understand where they would place different 3D objects. It should match the metaphors that you use, right? It should again match with user's mental model, and you should be able to understand how they can place different virtual objects, what size, and how it is proportional to the environment that is being given, right, or etc. You give control to the users wherein they are easily able to navigate with these virtual elements, right? It is possible for users to place virtual objects in unwanted location and delete and rotate if some mistake happens. So it should support different actions. And gestures and other mechanisms through which the users interact, they should be uniform all through. And it should indicate user whether certain manipulation is happening or not, right? So what you're seeing over here is basically it tells the users about certain function, how clearly they are able to manipulate information. So these are some guidelines that become really important, right? You have to at the same whatever principles you have in 2D, we are now also applying them for designing augmented reality based interfaces, wherein you would like to minimize users' cognitive load and providing them with flexibility to design efficiently, right? So both type of users, novice or expert, they should be capable enough to use your interface. Um, and again, what you see over here is that you are helping users understand if, so for example, in AR, when you're projecting information, sometimes there is reflection and the object is not placed. So it is able to give users some sort of, notification that maybe you should try a different place. So it is helping users recognize and discover, diagnose different type of errors that are happening. And again, help in documentation, right? So you can just bring in certain aspects and help users look into this part that, okay, now you need to do a particular action. Simplicity is one thing, right? Because you have to keep UI simple. Now, imagine if you have something like this in front of you, a lot of information in front, right? And again, it'll eat up your cognitive resources, the mental resources. So instead, something like this makes more sense, which is lighter for users to understand. And in case the complexity is inherent, you can give capabilities to the user to customize the amount of information. And there should be a proper structure to the UIs. I mean, you need to sort of create a structure in the sense it should be the user should be able to interact and make sense of what is happening, right? So complex tasks can be broken down into different subtasks. Over here, what you're seeing is that similar controls and contents, they have been grouped together in different hierarchy. So user can really understand in this radial menu how they would interact. And visibility, like again, so visibility is what makes things obvious for the users. If they're doing a particular action, they should immediately understand what is going to happen, right? And what are the options available for them. And some more design considerations when you're really talking about spatial interfaces. So environment, movement, and onboarding, they take the front seat. One interesting concept being the proxemics, which really understands how an environment you can place or anchor different elements, right? And this has been taken from like social sciences, which looks at, which sort of studies different human spaces, looks at intimate space, personal space, the social space, and the public space, right? And they have different dimensions to it. So, for example, if you're really talking about an intimate distance, which is quite close to the user, somewhere around, around 1.5 feet, or a social space or a personal space, which moves somewhere around 4 feet, then moving towards 12 feet, which is the social space, or public space, which is somewhere around 25 feet, right? So this can be interestingly used when you are creating AR experiences. So face filters use something called as an intimate space, right? You can anchor menu items to the hand, which is again in an intimate space. Or you can simply you can create different AR experiences that are dealing with personal spaces. So for example, in this game, You're able to understand the interactions that happen at different spaces, right? So maybe two people can play this easily by interacting with the markers, moving them here and there. So this goes in a personal space. Or something which is in a very large environment, which is really in the sense encroaching the social space or the public space. So this is one experience by Mumok Museum, Mumok AR, wherein you could just point your device to the building of this museum and it would just move up and these interactive visualizations would be played. So the gradient changes. So you're moving from an intimate to a public space, right? And you can decide accordingly how you would like to place the content. Another important pillar is the movement because the user will be using this quite a lot. So whether it's a smartphone or whether it's a head-mounted device, right? The user has a limited field of view, and what is the primary task the person has to do becomes important. So understanding whether if they're using a mobile phone, is it a seated experience or are their hands moving and or are they standing or are they moving around in the world? This becomes important in terms of creating different experiences. Onboarding again is important because the user needs to immediately understand what is happening. And we have been using this in normal apps. Similarly, with AI, you see that as you're able to move along, like this marker, which tells the user where to place the object, right? And there are different ways in which interactions can happen. And this becomes important. And there may be different, there can be further depth to it, right? Wherein you can just have either a direct form of manipulation or direct ways in which people can interact with information or indirect ways through GUI elements, right? And that may depend on the task or activity that you're targeting, but interactions are important to understand how people will interact with the overall experience, the virtual objects, in case they want to do a particular task or in supporting different activities. Now, these are some guidelines that exist, right? Some things that we have taken from UI design and UX design and condensed them in the ways in which you can use it for AR and VR. What is the design process through which you sort of create these things or these experiences? In fact, there have been ways in which you are dealing with theory and you observe the users and then you create a report, right? But such an approach wasn't very useful or helpful in the longer run. And we eventually said that if you're designing interfaces, we need to bring in users and design with them. And hence, different aspects of co-design came in, or different ways in which human-centered thinking is or human-centered design thinking is propagated. In fact, design thinking is working on this principle quite a lot, which sort of empathizes with the user, tries to understand their needs, and we capture these needs by talking to the users, by going in their context, taking interviews, observing them, and then eventually defining the clear problem statements, right? And different ideation exercises are then taken in brainstorming and ideation through which you can create different concepts, creating different fidelities of prototype, maybe low fidelity or high fidelity, and then testing it with the users again and again. Much of it has also been driven by the understanding we have in HCI. For example, the Nelson's 7 cycle, which dealt with Gulf of evaluation and Gulf of execution, that if a user has to do a particular task, the interface display, the interpretation and evaluation should be easy for the users. And similarly, the user should also get an immediate feedback on what is happening. And there have been different aspects on theories, which sort of this human information processing theory, which looked into understanding how well we process the information, right? And such type of things really step in when we are looking at a task-centered approach. But oftentimes with these theories, what is happening is that we are only considering human as an input output, as a computer itself, that you have an input and an output, right? The social aspects are completely ignored in certain cases, and in which way then different theories step in, like the activity theory. There have been different frameworks in software engineering, like this Lucid framework, which tries to understand how you can build different uh, interfaces and softwares together through an iterative cycle. which looks into different models of the users, and then through iterative feedback defines what are the tasks the user has to do, right? And based on that, it defines the overall interaction design. How is it going to look like? What is the language they are using? What objects, layouts, etc. All these things are being used, right? Or something that was proposed by Goldstein. So these are some examples wherein which the ways in which people have been designing these applications. So overall, the goal is really to create something which is usable by user, which is highly usable by users, right? And what you're really seeing is that it becomes more towards a task that a user has to do, and then this continuous evaluation happens, and then we understand how is the user involvement, what is the representation and the metaphors that are being used, then creating low fidelity prototypes, and then working so on and so forth, different frameworks as this. So what I'm proposing here is one of my frameworks that I particularly use, and this came in from my experience when I was teaching XR to like for different batches. And I noticed that it becomes difficult to understand or grasp these concepts. Primarily, it's not like the literature is not existing. It's primarily students are unaware of it. But at the same time, it also becomes important to understand what type of AR or VR experiences you will use, right? So what I'm proposing here is one of my own cycle, which really deals with idea, reality, content, interactions, and evaluation, right? Wherein you ideate a number of ideas. I mean, this can either be done through sketching, right? Wherein you quickly sketch things out, or you try to understand if you want to create an experience, what is it that you want, right? Deciding on the reality then becomes quite important, because we have seen we have AR, we have VR, we have augmented virtuality, augmented reality, the whole spectrum of it, right? So this is one example of one of the projects which was done by these students, wherein it sort of did this whole sketching and storyboarding as an exercise in terms of understanding how virtual contents are to be placed, and then eventually designing the whole VR experience. Um, in terms of reality, Milgram's continuum is one aspect, right? But it sort of in it, to my understanding, it sometimes does not give this complete depth on the display technologies that we have, right? So I sort of started exploring different type of continuums that can be there in the taxonomies for display, right? So this is what I stumbled upon in one paper, which really mentioned that with augmented reality, you can have assisted reality, which is really, I would say, in terms of weaker AR, right? You have these Google Glass type of things where some screen is there and some information is being projected, and you're able to see this content. Although the presence component is quite low in these ones, but as the presence component increases, it moves towards a mixed reality component wherein it is spatially aware. So what you're seeing over here is an AR wherein it is not aware of this complete space, right? You can see the penguin's wing is in front of the chair. Wherein with mixed reality or a higher fidelity, what you can achieve is, or with a more local presence, you can achieve, you can provide occlusions to virtual objects. So this view primarily takes into like I said, different views that have been existing. So Milgram's view, which primarily deals with mixed reality, which is dominant in that sense, and a new framework that really deals with treating AR as one separate entity and VR as one separate entity based on local presence or the telepresence, right? So with AR continuum, you have assisted reality and you have mixed reality. And with VR, you have optimistic or a holistic VR, right? The presence that component that you're bringing in over here, which really deals with, let's say, for example, 360 videos or to a fully immersive experience wherein the user is also able to interact. I sort of just modified this in terms of to also include something called as tangible XR, what I discussed initially, because uh, we see amalgamation of these tangible interfaces and with AR, VR now fairly recently. And what it is proposing is that you have this tangible and tangible VR components. What I mean by tangible AR is that you are able to sort of interact with physical objects through AR, right? Or for example, in this one, you have these different markers. When you bring them together, these digital elements, they start interacting. Best understood through examples. So this was one of the early works, I think the fairly recent works that was done by one of the faculty members over here at IIIT Delhi, which is looking at how you can, um, like um, combine or couple the digital information with the physical objects. Or, for example, this particular work, which is pretty interesting in the sense that it sort of tries to visualize information to globes, right? So what this one really proposes is uh, different ways in which you can interact with physical objects and digital information. So it is like a tangible visualization that can be created. So so this again brings me to this part. You have this whole cycle where you have now decided on the reality components, right? And after that, after you have fixed on the reality part, you look at the content. And this can really be done through low fidelity prototyping. And you have different techniques for it. You can either use paper prototypes or you can use enactments. You can use body storming and other techniques. The best way or the most simple way is that uh, you first decide what is to be there in these applications or how your idea further builds up, right? What is going to be the main components? And you create storyboards and you create low fidelity prototypes with them. And these are some of the tools that can be utilized. For example, the secure rectangular grid, wherein you decide where you would like to place content in this one. So this is one example where you are seeing that you can place different UI elements over here or maybe virtual elements. Another things that can be used is this VR's storyboard template by Vincent. And this is pretty interesting because this gives you a storyboard of sorts like step one, steps two, step three for developing your application. You can do room storming and body storming. These techniques sort of understand how you can maybe how your whole environment is going to be like. So this is one of the examples from audience experience by Katie Newton. And considering different field of view, how you would place users, how you will design environments, in case the environment is 360, in case it is 180. So you can perhaps use these things, right? Interactions in AR are of different types, and this becomes the next pillar for your UX cycle, wherein you try to understand how you will embed different interactions. Um, what is the task that a user has to do in AR, right? And what are the modalities that can be used? Touch being the predominant one. You can use different devices. You can create tangible interactions. You can have gesture-based, voice, gaze-based, or a brain-computer interface. So different tasks that a user can perform in AR, right? In terms of selection of information, maybe it's a 2D selection, maybe it's 3D, maybe they're manipulating different objects, maybe it's a continuous interaction, or maybe it's a discrete one, or some text has to be input, right? And when you're talking about virtual reality, you have 3D manipulation, you have locomotion and system control. With locomotion, primarily, it's like how you're able to move from one space to another, right? So it can be based on different mechanisms. It can be based on treadmills. It can be based on redirected walking, where you're just walking in one place. Right. So either you're locomoting through a treadmill, just comes this, or you're just walking in one corridor at one spot itself, right? And then there are different interaction techniques that you can do use for selecting different virtual objects that are there, right? You can have virtual hands, you can have recasting, wherein you can just point and select different objects, bring them together, different other techniques exist. And in fact, why I'm bringing this is because n number of techniques are already existing, but we see less and less use of them, right? So techniques like flashlight, where you are easily able to select small objects at a particular distance, and then how you'll evaluate your whole experience. So you have different ways in which you can perform evaluations of your experience. You have heuristic evaluation, you are doing some usability testing in case you would like to find out whether a particular task is there and whether a user is able to use it or not. The simulator sickness scale, the presence questionnaire, feedbacks, task performance metrics, etc., right? So different ways in which evaluations can take place. So altogether, the key takeaway being that when you are designing for users, you really need to consider aspects of the cognitive load, the performance, and the situation in which these users will be, right? You have to bring interactions to the user, wherein user are easily able to interact and work in your environment, and you have to be mindful of the physiology. Understanding human factors goes a long way in this case, and in terms of understanding how we perceive information, right? So for example, if any information is placed below zero point 0.5, it may lead to an eye strain, right? So a good zone maybe will be somewhere around 0.5 meters to 1 meters or 1 meter to 10 meter, right? Wherein how you're able to place the content comfortably or the UI elements comfortably, because beyond 20 meters everything then becomes just like at a particular distance. So generally it is a good practice when you're placing your UIs to bring it from 0.5 meters to maybe let's say 10 meters, or considering the ergonomics, right? How so it really becomes important to understand where you would place the content, right? And uh, we have taken things from human factors in this case. Understanding the comfortable position. So, right, that you can maximum 20 degrees is what you can move your neck up versus when you're moving the chin, like your head's down, that you can go till maximum 12 degrees because of the chin that is coming in. So, placing experiences between these zones, it becomes important, right? And content that is placed somewhere around 77 degrees is easily visible, but beyond that, there is a strain neck, and behind is definitely the user cannot see the content. So this has been taken from Mike Elger's visual methods for VR, wherein different zones have been created based on guidelines from ergonomics and human factor studies, which tells about how where you would place the content, right? Which also tells about the work zone and workspace for the users, which you're looking at, because ideal angle for work when you're looking down, right? And how you would place the content. So altogether, this is one grid that can be utilized for creating uh, or utilizing your for designing UIs or for designing your content. Where you are going to place your content, what is the work zone. This is basically the peripheral vision. So where you are going to place things in the periphery, right? And the 60-degree cone is really something which is comfortable for users to look into, and that's where you would like to place your core UI elements, right? Something like this. So this is the comfort zone for your eye where you're looking at. So it is within this particular part dominant that you would like to place your UIs. Right. Some other concerns that really step in when you're talking about VR is in terms of affordance, which is really telling users what they're doing and how they're going to do it, in terms of the movements, uh, text and image legibility, ergonomics, and sound effects, right? So with these guidelines, what you're seeing is that we are able to understand how humans behave in a particular way and what are the concerns in terms of understanding the information, in terms of the physical limitations, right? Um, and so far so good, right? But if you really want to create UIs or interfaces that are spatial in nature, perhaps the approach may not come directly from traditional human computer interaction, but rather on architecture interfaces, right? So this is one article by David Sang, I believe, in the Interactions magazine, that tries to understand how like architectural practices um, embody everything, right? Wherein it is looking at human to human interactions and the interactions with those objects, and surfaces, different colors, materials, etc. And what if you are to design your interfaces that merge well with the interfaces around you? Because if you really look at architectural practices, you live in the interfaces, right? As opposed to interfaces being separate from the human body, you are actually inside a room. You are able to interact with tables, chairs, and all, and they're simply an extension, right? So one way is to perhaps look at situated embodiment, where the idea is to integrate people, objects, and environmental conditions, and it can really be based on different, like levels of embodiment, wherein you have a private space and a private or a virtual person you are interacting with, right? So it can maybe create a room, or maybe it is in a public location with yet a private, you know, uh, the gradient is towards the private aspect. Um, or they can be different ways in which you are moving towards, and you have both like physical and digital elements combined together. Um, so it can either be based on others' embodiment, or it can be based on virtual objects, or you can be completely in a different virtual space together, right? Um, the second concept really being that depending on the information architecture of the user and the precedence of information that you would like to show to the user, is it possible that we change or create some flexibility within the UIs, right? And give this a dynamic uh, prospect, which sort of brings in components and merges them with the environment, giving it some sort of a continuity, right? So this the third concept being the ambient continuity, wherein you have flexible interfaces that are able to morph in your peripersonal or extrapersonal spaces, and depending on what requires more attention, what does not, what can go in the foreground or the background, right? And based on that, the whole interfaces can be then designed. And it does not limit over there, right? Because with current technologies, it is now possible where it is able to understand the whole environment. You can place UI elements or information on the wall or on different openings, on ceiling or floor, corners, and whatnot, right? So we see a lot of potential in terms of designing spatial UIs, and a lot of interesting guidelines. And it really becomes like an interdisciplinary work that you're doing, wherein you are able to take in things from architecture, you are able to take things from cognitive science. So the whole discipline of interaction design is that way, right? The scope is quite broad, and you take in knowledge from different domains to weave in particular artifacts, right? So this was one of the cycles, like Howard Gardner's trend about technology. And this is from 23, where they told about how different technologies, right, like digital twins and metaverse, they are going to be a boom. Fairly recently, we have started seeing India investing heavily into animation, visual effects, gaming, and comics, right? And you see different compendiums being prepared and reports in terms of expanding in this space. Um, According to these reports, the market is growing, right? And we see spatial computing as one of the things that is coming up. And it is like a really emerging market. And in India also, across worldwide and in India, the whole market size is projected to reach somewhere around 624 million, right? Even more. And we are seeing different trends. We are seeing not just spatial computing devices, but we are also seeing trends in terms of IoT and other devices that are being brought in together. And that sort of opens up rich potential for exploring spatial computing, wherein both digital and physical worlds get combined. So the idea really being that you move away from a device-centric view to more human-centered, right? Wherein devices take the secondary precedence and humans take the primary precedence, right? And moving towards different revolutions. And what you're seeing over here is one example by Tangible Media Labs. It sort of tries to bring in this physical and digital environments together, the whole idea behind tangible interactions, okay? or or in terms of new capabilities that are being introduced. For example, this Project Swali, which really introduces this miniature radar through which you can interact. easily, then creating more natural interactions, right? And coupling them with spatial computing can provide rich opportunities. Or seeing examples like this, wherein now Gen AI is becoming, it can be coupled with XR experiences together, or beam technologies where you're just able to project people in different space, right? So yes, new modalities, new paradigms, new taxonomies are being created, and with potential of technology, we are seeing that we are moving towards something like cross reality, wherein multiple devices, multiple realities, they're all combining together, right? And it is really an interesting space to work on. So with this, I would close my lecture topic over here. And in case you have any questions,